Find the critical depth and critical velocity of water flowing through a rectangular channel of width 5 meters when discharge is 15 meter cube per second. So here a rectangular channel is given and we have to find critical depth and critical velocity. So here first of all note down the given data. Here given width of rectangular channel, width. So width of rectangular channel W is equal to given 5 meters, and also given discharge. So discharge Q is equal to 15 meter cube per second. Meter cube per second. So unit of discharge, SI unit of discharge is meter cube per second. Here we have to find critical depth. So two parameters, two things. So the first thing is critical depth, and next we have to find critical velocity. Critical velocity. So we have to find these two things, critical depth and critical velocity. So how do we get critical depth and critical velocity? So generally for a rectangular channel, the critical depth is given by, for a rectangular channel, here given rectangular channel, so for a rectangular channel, the critical depth. So critical depth generally denoted by small y suffix c, yc. So C for critical. Okay, na? So here YC represents critical depth. Is given by or is given as. So formula YC is equal to Q square by G whole power 1 by 3. Q square by G whole power 1 by 3. This is the formula for critical depth of rectangular channel. So in case of rectangular channel we use this formula. So critical depth YC is equal to Q square by G whole power 1 by 3. What is Q? Where Q is equal to, so here Q ante meaning right? Where Q is equal to discharge per unit width of the channel section. Discharge per unit width of the channel section. Okay, na? Channel section. So here Q is discharge per unit width. So we can write it as Q is equal to discharge denoted by Q, width of the rectangular section W, Q by W. Small q is equal to capital Q by W. Okay. So we have to find YC. We need YC here. Critical depth. To find critical depth, we need Q, and what is G? Here G is acceleration due to gravity. What is the value of G? Approximately 9.81 meter per second. Okay, na? So this is the value of G. G means acceleration due to gravity. Now first of all let us find small q. Here small q is equal to capital Q. Capital Q means discharge. So here discharge how much? 15. So 15 meter cube per second by width. W means width. So width of the channel section is 5 meters. So 5. 5 ones are and 5 threes are. So here what is the unit? Meter cube per second. Here what is the unit? Meter. So 1 meter get cancelled. You will get 5 ones are, 5 threes are. 3 meter square per second. Therefore small q is equal to 3 meter square per second. Okay. Now let us substitute this value here. You will get critical depth. Critical depth YC is equal to, so q square means 3 square by G value 9.81 acceleration due to gravity whole power 1 by 3. Okay, now if we calculate this value, you will get critical depth. Now YC is equal to 3 square. So 3 square value 9. 3 3s are 9 by 9.81 whole power 1 by 2. So if you calculate, you will get approximately So here I got 0.9717 meters. This is the value of critical depth. Next we need critical velocity. Critical velocity. So critical velocity is denoted by Vc. So capital Vc is equal to, so in case of rectangular channel, critical velocity Vc is equal to root over G into Yc. So Yc means critical depth. So what is G? Acceleration due to gravity. G value how much? 9.8 into Yc. Here what is the value of Yc? 0.9717. Okay. So if you multiply if you find square root of this value, you will get critical velocity as 3.088 meters per second. 3.088 meter per second. So velocity unit meter per second. Critical velocity unit. So what are the final results? Critical depth is equal to 0.9717 meters and critical velocity is equal to 3.0808 meter per second.